All of us would have seen this spectacular image of the black hole at the center of the Milky Way galaxy. And this was captured by a telescope which is called as the Event Horizon Telescope. Undoubtedly, this is one of the most stunning images one would observe in an astrophysical context, but also it is an achievement par excellence in terms of the technology what has been used to obtain this particular picture. Now, what is interesting is that this particular structure also has a singularity, and this is very common, for example, in black holes, where the center of that particular object represents a singularity. What I want to draw an analogy is to a phenomena in optical physics, which is equally interesting. And it is always kind of fascinating to see that you would be able to observe some interesting analogies between various subdisciplines of physics. And I would actually just show you something very interesting. Now, what you see in this particular picture is essentially an optical vortex, which is generated in my lab at ICER Pune. So this structure, unlike the one what you're seeing to the left, is of the dimensions of few microns. But what is interesting is that these optical beams, this is essentially a laser beam, which has been kind of structured to carry a singularity. Now, this particular laser beam also carries angular momentum, and therefore there are some very interesting kind of analogies one can draw between these kind of structures. Of course, the size and the scales and also the origin of the singularities are very different, but here in this particular case the singularity is with respect to the intensity. And interestingly, one can also obtain singularities in terms of polarizations and various different aspects of light. Now, in addition to this, there has been a lot of work which has been done, not only from my group. For example, this picture is from one of our papers, but there is a tremendous amount of work done across the world in optics and photonics community related to optical vortex. It is not just confined to only kind of realizing such beams, but there are also very interesting questions raised in the optical physics community. For example, people are looking at various different analogies between astrophysical scenarios and optical kind of laboratory experiments. For example, one can observe a fiber optical analog of the event horizon, which is something very important in the context of, let's say, black holes and other astrophysical sources. This is a paper which appeared in Science in 2008, and it actually has some very interesting analogies drawn, specifically in the context of the way radiation can emerge out of the horizon in the form of Hawking radiation, and what is the optical analog of such kind of effect. It is essentially a classical optical effect, and therefore there are some very interesting questions one can raise in the context of how these observations can help us understand some large scale galactic kind of sources and other kind of forms, which has created a lot of buzz. If you're interested more in understanding also the singularities, especially in the context of optics, I would strongly urge you to have a look at this particular book, which is titled as Singular Optics. There are some fascinating questions related to the singularities, what one can obtain in such kind of situation. And also it draws some neat analogies between various forms of effects what you observe in different scales and in different domains of physics, and bring it to the table in terms of optics and photonics. So what is fascinating is to see that optics play such a critical role in bringing out these kind of phenomena. The spectacular image what has been captured of the black holes is also thanks to some very sophisticated imaging techniques, and this is indeed a great observation. And I have also linked all these papers, including the main resource of the black hole, on my blog. Do have a look at it. Thanks. Bye.